Hi students, this is Mr. Yao. Today we're going to talk about 6.2, where we will learn about dilation. Start with the definition. Dilation is a transformation that produces an image emphasizing on it is the same shape but is different size. So if you recall, we have learned in Unit 5, if two shapes are the same but they have different sizes, they are similar shapes. And we can also use that symbol to represent. So basically, dilation is talking about similarity in shapes. Before you have learned about dilation, but you have always used the origin to actually dilate. However, in this lesson, we're going to use more than just the origin. So we have something called the center of dilation, which is a fixed point in a plane about which points are enlarged or reduced. And if any of you have done anything that's perspective drawing, you would know, for example, if you're doing 1 point perspective, like this is a point and you try to draw your perspective drawing, that 1 point is going to be your center of dilation. Of course, you have 2 point perspective, then both points are your center of dilation. And since we're changing size of the shapes, we're going to have a scale factor emphasizing it's a ratio, but it's from the new figure to the original figure. So the fraction is going to be new over original. And that is the one fraction, only one way to represent the scale factor, new over original. If that number is bigger than 1, then it's an enlargement because you're going to end up with a larger image. If it's less than 1 but bigger than 0, it's a reduction because you end up with a smaller image. And of course, if it's 1, that means we're not changing it, and that's where we got a congruent figure, which is why in Unit 5 we have said congruent is just a special case of similar. Same thing here. Now let's have a look at how we can actually dilate. Example 1. Let's first highlight our center. The center is 0, 0. So in this case, we're using the origin. Next, it's a scale factor of 4. So we're going up, and we're going to actually dilate all the points. You kind of have at least 2 different ways to do it. First, you are going to pick 1 point to dilate that point. So I'm going to pick this point on the left top corner. And you're going to kind of count how far away is it from the center. So from the center, I'm going up 1 over 1. Since I need to dilate by a scale factor of 4, that means this up 1 is going to become up 4. 1, 2, 3, 4, right here. And then it's going to go to the left. Instead of 1, it's 4. So 1, 2, 3, 4. That's where my point is going to end up with. That's how I dilate by 4. You can also do the same thing for all the other 3 points. So for example, this point on the right side, that's up 1. Use a different color. That's up 1 over 1, 2. So in this case, that means I'm going up 4, since I'm dilating by 4. Then 2 times 4, that means I'm going to the right by 8. So 1, 2, 3, 4, 5, 6, 7, 8. That's where my next point is going to be. It's corresponding with this point. And you can keep doing the same thing for the other points. Bottom right, that's down 1 over 1. So I'm going to go down 4, 1, 2, 3, 4, then 1, 2, 3, 4. Going to the right by 4. And for the left point, this one I'm going to use a slightly different method. So you see that side is exactly on the grid, and this side is 3 long. Which means if I actually want to dilate the 3 long, I need to change it into a 12. So that means this bottom side should actually be 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's where my point is going to end up being. And of course, you can still do the going down 1, going left 2, but after dilation is going down 4, going left. Since we're dilating the shape, make sure you connect all the points because we're not just dilating the points. So connect them. And with this top side. And this is the other side, bottom side right there. In order to show, hey, we actually end up with some similar shapes, we are going to connect all the corresponding points. So these two are corresponding, so connect them. Extend, you will see it actually go through the center of dilation. Connect these two corresponding points, extend, still go through the center of dilation. Same thing with this one, connect, extend, connect, extend. So now you see they all go through the center of dilation, and we're done with example 1. Example 2, dilation still with center at 0. So you see this is compared to the center. I'm going to highlight the center. I'm going to deal with each point separately. So this top left corner, that point is 2 to the left, then up 3. I need 1/2, which means I'm going to go 1 left and then 1.5 up. So I end up with a point right there. So right point, top point, that's 1, 2, 3, 4 to the right, then 1, 2, 3 up. So I'm going to go half of that, so 2 to the right, then 1.5 up. Bottom right, that's 4 to the right, then 2 down. So I'm going to go 2 to the right, then 1 down, right there. For the bottom left, 1, 2 to the left, and 2 down. So half of that, 1 to the left, then 1 down. Again, make sure you connect all the lines, all the vertex. I end up with this smaller rectangle. Last thing, connect all the corresponding points. Connect them, and this one, connect them. Connect that one, and connect the last one. For this example, you will see more clear. These lines that we connected, and for example, that line and this line, you can see that they're not just forming a straight line. So it really depends on where your center of dilation is. It actually tells you it is going to be a straight line all across the diagonal. So in this case, it is not. Which means you can't just assume, oh, I can just connect the diagonal, then I'm going to end up with the line that I want. No. Corresponding points, they should all meet at the center of dilation. Now let's think one step further. For this question, let's count the bigger rectangle, see how many little squares we have in there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. We have 30 of them. Okay. It's saying dilate by a scale factor of 1/2. And how many do you think we're going to end up for the smaller one? Pause here. After you think about it, you might wonder, oh, maybe it's just a half, it should be 15. If you actually count it, that is going to be 1, 2, 3, 4, not that 4, 1, 2, 3, 4, 5, 6. And these two together is 7, so it's actually 7.5. So instead of the area changing by a half, it's actually changing by a half times a half, which is a fourth. Each dimension is changing by a half, so consider the other dimension also changing by a half. When we count the area, it's going to be a fourth. So if that means we actually talk about volume, for example, that's going to be 1/2 times 1/2 times 1/2, which is end up being 1/8. Just keep that in mind. The size change is going to be depending on the dimensions. That's example 2. Example 3. Same idea, -1, -1. This time, we're not doing the origin. So let's highlight that point. And we're counting how far away is each point compared to that center of dilation. So this point, for example, is 2 up, 2 to the right, dilation by 3, which means I need 6 up and 6 to the right. So right there. And this graph is actually going to be a bit out of the area. So this point, that's 2 up, 4 to the right, so I need 6 up. Since it's 4 to the right times 3, that's 12 to the right, which is going to be around here. Then this top point, that is 4 up, 2 right, so I end up being 12 up. That's 8, 9, 10, 11, 12 up, then 6 to the right, which is around right here. I'm going to connect them, make my triangle shape. Last thing, connect them corresponding points so that you can show they all go through the center of dilation. That is example 3. Example 4. Center of dilation is -4, -1. Oh, so you see this is actually a point on the bigger shape. So let's actually have a look. 1/3, this point right here, well, first this point itself, it doesn't need to move. It is just on that point. This point, that is 3 up, 9 to the right. So we need 1/3 of it. So we're going to go 1 up and 3 to the right. So end up being right here. This point, there's no up and down. It's directly 12 away and need 1/3 of it. So it's going to be 4 away. This bottom point, that is 9 to the right, and then 9 down. So now I need 1/3 of it. We're going to go 3 to the right, then 3 down, and that's my point right there. Connect the shape. Last thing, connect all the corresponding ones. So these two are corresponding. That's going through the center of dilation. These two are corresponding. And these two are corresponding, all going through the center of dilation. That's example 4. Next, example 5. Same idea, dilation of 2 about 1, 2. So 1, 2. This is the point. And we're going to dilate it. So let's have a look. First, this H. That is going to be a 1 to the right. Right now, I need to dilate it by 2, so I need to go 2 to the right, which is right here. And since they're labeled, and we use prime to represent the new points. This little apostrophe or single quotation mark is called prime in math. Now I, that is 1 to the right, 4 down, so now I need 2 to the right, and 8 down, which is going to be right here, labeled as I prime. If the points are labeled, make sure you also label them. This G is 2 to the left, then 1 down. Now I need twice of that, so it's going to be 4 to the left, and then 2 down, which is right here. I just need to connect them with my points. This is G prime, connect, and connect. Make sure you connect the corresponding pair and going through the center of dilation. Okay, that is example 5. Example 6, same idea. 3, -2 first. 3, -2, which is around here. And you see this time the center of dilation is actually inside my shape. But that doesn't change anything. We still dilate it the same way. So let's have a look. V is 1 to the right. I need 1/2 of it, so it's going to be right here. That's my V prime. W is 2 to the left, 3 down, so I need 1/2 of it, which is 1 to the left, 1.5 down, which is around here. That is W prime. T, 1 up, 4 to the left. I need 1/2 of it, so it's going to be 1/2 up, then 2 to the left. So T is going to be right there. So T prime. U, that is 1, 2, 3, 4 up, 3 to the left. I need 1/2 of it, so 2 up, 1.5 to the left. So that is going to be U prime. Now it is time to connect them. And that is my shape. In case you didn't notice, all the sides, they are actually parallel with all my original sides. Last thing, connect the corresponding points to indicate that I have, it's all going through the center of dilation. These two, and these two. Okay, that's example 6. Next, let's have a look at an example that's talking about how to find the center of dilation and also the scale factor. T, again, scale factor, the ratio is going to be nu over original. We'll have it backwards. Example 7. In case you didn't notice, for previous examples, all the corresponding points will connect to actually go through the center of dilation, which means if we're given both figures, if we connect them, they should actually all go through the center of dilation. So all I need to do is find the corresponding points, and then I'm going to connect them. example, I'm going to connect my B and my B prime. So right here, I can kind of see my B and B prime. They are going to go through that point. Okay, my A and A prime, they're going to go through that point. And lastly, my C and C prime. Well, clearly, they all go through this one single point, which is at -2, 2. Okay, next, I'm going to find my scale factor. So since I don't actually want to calculate all the sides, you totally can and see, oh, maybe you calculate this and you calculate this, see how far, how different they are. But what you can also do is you count how far away is it from the center of dilation. So for example, for C, this part, that is 5 away. Then from the center of dilation to C prime, that is 2.5 away. Again, new over old. To indicate it's a new one, we can see the little prime. So it's going to be prime over the regular letter, 2.5 over 5. If you simplify the fraction, that is going to be 1/2. So the scale factor is 1/2. Let's have a look at example 8. Connect the corresponding points and see where they actually go through. So if you connect O and O prime, okay, connect P and P prime extended, M and M prime extended, N and M prime extended, you actually will see they all go through the origin. So in this case, my center of dilation is 0. So now it's time to find a scale factor. You have a couple options. First, you can find the side. Each side actually compare with their corresponding side to find the scale factor. Or you can actually use the lines that we draw to find how that changes. Another way is you can kind of count the rise and the run compared with the center of dilation. So that's what I'm going to do for this example. My center of dilation is at 0, 0. So if I actually want to get to M prime, for example, that is going to be down 0.5 and then left 0.5. But if I actually want to get to my M, that is going to be down 2 and left 2. So if you compare them, new to the old, this is a new one because they have the prime. It's basically 0.5 over 2. After simplifying, is 1/4. So my scale factor is 1/4. For example 8. Example 9. Let's connect the corresponding points. Connect corresponding points. Connect corresponding points. So we end up with this point right here, which the coordinate is -2, 1. And this one actually has something easier we can use because this section, this line is actually on the grid. So it's easier to count. First, count that is 4. And this little portion right here, that is 2. Again, new over old. So the new one, the prime is actually 4 over the original, the old one was 2. That simplifies to be 2, scale factor 2. Last one, number 10. Connect them, U prime with U. Extend X prime with X, W prime with W. We're going to connect all of them. And you will actually see they go through this one single point right there, which coordinate-wise, it is going to be 3, -5. Now you can actually count. Again, we have a line, right? Either this one or this one, they're both on the grid. Since this is smaller, I'm going to use that one. So this part is 3, and this little portion is 1. New over the old, the new one is the prime, so 3 over 1, which is 3. And that is example 10. That is everything for 6.2 dilation. Thank you.